Okay, we are going to look at an example of a mixture of silver nitrate and sodium chloride and determine whether or not a precipitate would form. So if we start, first of all, the fact that we're given the KSP for silver chloride tells us that we are going to evaluate whether or not the silver chloride will precipitate. When we combine silver nitrate with sodium chloride, there are two potential products. One would be the the sodium nitrate, which is still going to be a soluble salt. The other one would be the silver chloride, which according to solubility rules will precipitate because it is a slightly soluble salt. Again, the fact that we are given the KSP of the silver chloride tells us that. The way we're going to do that is to calculate a Q, or reaction quotient, for the AgCl at this point. And the expression for the Q is going to be the silver concentration times the chloride concentration. If you can write that expression directly, that's great. If you're not sure how to write that, remember you can always go back to writing a dissociation equation. And that might help you to write the expression for K, which is the same as the expression for Q. But we're really not going to do any ice tables or anything. We don't need this equation. So if it helps to write this equation to help you get this equation, then please do that. But if not, it's unnecessary. So at this point, I'm just going to get it out of the way. Once we calculate our Q, we can compare the values of Q and K, and if Q is greater than K, we will get a precipitate. Okay, and so that's going to be our approach to look at this problem. So let's start with calculating the molarity. Now we're given the silver molarity, right? We're given the silver molarity. We are told that we have 10 milliliters of 0.010 molar silver nitrate. But our silver molarity is not going to be 0.01. The reason for that is we are also adding 10 milliliters of sodium chloride. And when we add the 10 milliliters of the sodium chloride, we're not adding any more silver. So we're going to go to a total volume of 20 milliliters, but we're not adding any more silver. So essentially we're diluting the silver with the sodium chloride solution. Our dilution equation is M1V1 equals M2V2. And we want to calculate M2, which is the new molarity for silver. So dividing both sides of this equation by V2 will allow us to calculate that. My initial molarity of my silver is 0.010 molar. My initial volume is 10 milliliters. My final volume is 20 milliliters. So essentially I'm dividing it. I'm doubling the volume, so I'm halving the concentration. And that concentration then is going to be 0.0050 molar. That will be my silver concentration that goes up into here. Okay. Similarly, my final chlorine concentration, or my final chloride concentration, is going to start with my initial value of 0.00010 molar. I'm diluting that by 10 milliliters over 20 milliliters. And when I do that, I will get a new concentration of 0.00005 molar. That value will go into my chloride, or my K, or for my Q, excuse me. So now let's rewrite the expression for Q from these molarities. My Q is going to be Ag plus times Cl minus, silver concentration times chloride. My silver concentration is 0.0050 molar. My chloride concentration is 0.000050 molar. I probably should have used scientific notation. I'm getting a lot of zeros there. But multiplying that out, we get Q is equal to 2.5 times 10 to the negative 7. If I compare that to my given K, which is 1.7 times 10 to the negative 10th, I see that my Q is greater than my K, and so my silver chloride will precipitate, because essentially we had more silver and more chloride than can coexist in the solution.